Previous videos, we talked about the corneal refractive index, the radii of curvature of the cornea, geometrical features of the cornea, and we talked a little bit about the lens. But right now in this video, we're going to talk about the curvature and shape and radii of curvatures of the both surfaces of the lens, which is another important part of our eye. So as always, we just look at it completely from pure optical perspective. So crystalline lens is this part of our eye that, here is the cornea, we have a liquid here, the stop, and this part of our eye which plays a very important role in keep our retina at focus, and I explained it in another video. So this part of our eye that we call it crystalline lens, or generally lens, has two surfaces: the anterior surface, which is the front surface, and the posterior surface. Based on a lot of research about the radii of curvature of the anterior and posterior surface, we can say the anterior surface is flatter than the posterior surface. So what does it mean? When we say the surface is flat, it means that it's close to a window. So the radii of curvature is bigger. So you can see, for example, here we have a study on 1972 by this study group, Low, and the method they use slit lamp photography, and the age and years, number of eyes between 23 to 77, and they studied on 92 eyes, and the mean plus a standard deviation of the anterior radii of curvature was 10.3 plus and minus 1.8. So it's in the range of 10.3. Another study 2 years later, 1974, with a different method, from the age of 3 to 82, 100 eyes, 12.4 plus and minus 2.6. And another research. So when we look at the data, it looks like the range is between 10 to 12. So if you have 11 point between 10 to 12, we have even 13 in some studies, and you can see the range of people, the number of eyes that they studied. But when we look at the posterior radius of curvature that I explained, that's the second surface of the lens. We have another set of data. For example, this one is, we have they studied both anterior surface and posterior surface. You can see even with the same method, for this one is 12.4, for the posterior surface 8.1. So when we look at the range, 6.7, 5.7, 6.1 is a little bit, the numbers are smaller than those. So we can say the posterior surface has lower radii of curvature, as we can see here. So this one has higher radii of curvature. So it means that this one is pretty close to be more flat because it has higher radii of curvature. As I mentioned always, for a flat surface, radii of curvature is infinity. So now you can see here, even visually is obvious that, this is a lens or crystalline lens of a ship. This is the front view. From the front view, you can see, and from side view, we can see that the radii of curvature of the front surface is like this, and the radii of curvature of the back surface is like this. So the front surface is more flat. So it means that, you can actually, if you want to approximate this surface with the radius, it's going to be a big radius. But for this one, it's going to be a small radius, or it's going to be a small circle. So we can see some kind of, even visually, this is a out of body actually measurement that, obviously they did it for a ship. And, even by eye, it's obvious that that surface, the radii of curvature difference between the anterior and posterior surface. So usually posterior surface is a little bit harder to measure because that's close to inside of our eye and you need to pass another surface. And that surface also, I have another video talks about asphericity for the cornea. That surface is not completely circular. So Asphericity is a kind of deviation from being completely circular. So we have a Q factor. I have a full video explaining that asphericity. As you can see, we have somehow a little bit asphericity for that surface also. So for the anterior surface, the number is -5 plus and minus 5. So that's a big range. -4, it's in that range. And for posterior surface, the range of the numbers is huge, -0.8, -2.3. So we don't have that much of very, one data, but that we can agree on, one set of data that we can say, okay, that's the good range. But, we have a different range of measurement. And, but as I said, posterior surface measurement is harder than anterior because that's inside of our eye. So we have more data on anterior surface. Thank you very much. Here are some references that I used for this video. Thank you.